Hello everyone. So today we'll be discussing this research paper, which is React, Synergizing Reasoning and Acting in a Language Models. As the name suggests, React, RE Reasoning, AT Action, Reasoning and Action together. Okay, so earlier it was published in 2023. Okay, so before that period, we were using LLMs or language models to separately, one for reasoning, one for taking actions. So when this came into picture, we came to think together, let's say, okay, we will do reasoning and action together in uh, same language model. Great. So let me just have a very quick overview over the research paper. Great. Okay, so in this research paper we use 4 data sets to test our language models, or basically to test our this React method. So one was Hotpot QA, Fever, LF World, and WebShop. So basically Hotpot QA I have already mentioned now. Kept it tab. Basically a multi-hop question answering. Multi-hop question answering means like uh, you ask, tell me the name of the country whose president, whose prime minister is Narendra Modi, or more better, tell me the capital of the country whose prime minister is Narendra Modi. Tell me the capital of the country whose prime minister is Narendra Modi. So first we will need to calculate. First we need to know that uh, name of the country whose prime minister is Narendra Modi. We will get the answer India. Now we have India, so we need to move to the next question. India, find the capital of India. Basically, moving from one question to another. This type of data set, hotpot QA. Fever was basically fact checking. So does it just check, mostly check like whether we use basically web uh, Wikipedia API here. So basically we wanted to check that whether our language model was retrieving or giving us uh, correct facts, or like in a certain way or in a shorter way. And this was dataset LF World. So basically it was a text-based interactive game like there was around six, I said there was really 6 cases. Say like, let's say, uh, grab the laptop and turn it on. Just simply I was doing some certain task. So you need to think, Acha, where can the laptop be? Maybe on a table, in the cupboard, on the study table, like these scenarios. And the web shop, it was really just navigating online shopping websites, and there was many more things into that this data set. Great. So we see more what was there. The tie synergy between acting and listening allows humans to learn tasks quickly. Great. React, synergizing, listening, and acting. Okay. And so basically testing. We were testing on by hotpot QA and fever. Great. There were some results. You say we were simply doing act and we were doing react, so react performed better. We'll go in more in depth. We'll again read the research paper line by line. We'll try to do line or paragraph wise. Great. Anything else? And here we were testing on LF World and WebShop. Basically, the previous two, the hotpot QA, and fever, they were mostly checking kind of your reasoning ability, and these were checking the decision making tasks like the action part, the LF word and the WebShop. They were more dominant on action side. Great. The results, comparison related works, decision making, record to conclusion. Okay, around 10 pages. Great. Let's move to the first part. Let's start it. He's just saying that while language LLMs are doing great, but till now we have discussed two things separately, the reasoning and action, both parts separately. So here is reasoning, it's saying chain of thought prompting. Just think of a term, chain of thought prompting. So here, let's say I have asked you a big question. So when we let me ask you a very big question. So you will think it step by step. So here what we do, we we output or we show our logic behind. Let's say you're solving a DSA problem. I ask you to solve, okay, sort this vector. So you will think, acha, okay, how I will sort, which method I will use. Okay, I will have sort stl, I can use heap sort or whatever thing. Whatever I'm thinking, whatever I'm doing the logic behind, I will display it. So think of this chain of thought prompting, showing intermediate processing or reasoning step instead of direct response. Rather than giving you direct answer, I will show you the intermediate logics behind it. So this is the meaning of chain of thought prompting. Instead of giving the direct response, I will show you, it will display or show the reasoning behind, in between, like how it get the answer, each steps, each reasoning between them. Great. That's in super. Just mentioning we are using uh, together both the reasoning and action part. Mm, so its approach is React. We get state of art results. Okay, great. New data set. Here this the result. This was important. Here is saying that React overcomes the prevalent issues of hallucination and error propagation in chain of thought reasoning by interacting with simple Wikipedia API and generating human-like task solving. Great. So, two other major problems, issues we face, issues we face is hallucination and error propagation. So, hallucination is, let's say there is an algorithm, it is generating a response. So, sometimes it generates facts which are wrong, or it should just make up some more facts. Let's say it says Mumbai is the capital of India. So it's a wrong fact. But suppose an LLM is generating this. So this is kind of example of hallucination. Hallucination, LLM confidently generate factually incorrect uh, response or made up information. So incorrect or made up information, hallucination. And second was error propagation. In error propagation, suppose we are given a problem, we have prompt, and we are solving it, like we are going step by step reasoning, and our first assumption is, let's say we say uh, India is a continent. We assume that India is a continent, and we solve the problem uh, using this concept, like using this fact. So in the later steps, we will get error because we have made the basic assumption, the first the assumption or the fact we took, it was wrong. So this kind of problems or issues or error are comes in error propagation. So that's little better. Error reasoning, early reasoning is wrong. Like let's say Mumbai is the capital of India, and this goes on further reasoning steps. Okay, so the two things, hallucination, like incorrect facts or made up information, error propagation. Our initial reasoning is wrong, so whatever reasoning we do later, it also become, obviously it will be wrong. Let's see, you say 1 plus 1 is equal to 3, and you are doing calculation based on that. Obviously things will be wrong. Okay, I won't go much into depth here. It's just showing how we actually work. Okay, so and this is just an example. It's a very interesting example. So basically it took a question from hotspot QA. Question is, aside from Apple remote, what the devices can control the program Apple remote was originally destined to interact with. Apart from Apple remote, leave it aside, what other devices can control the program Apple remote was originally designed to interact with. Basically, it shows four types of methods: standard, COT, मतलब chain of thought reasoning, and action only, and react, reasoning plus action. So in reasoning, in standard leave it. In COT you can see in standard there is no thought, there is no action, just you get a question and the LLMs give you answer. In chain of thought, let's say it is thinking. Let's think step by step. First, Apple remote was originally designed. Should I speak this part? So try to open the research paper on your screen, or maybe phone or laptop, so you can read it. Usually you can see the React one was working definitely better. Same, there is also example of help world. So in action there is only action, there is no logical thinking. And we can very simply say, let's suppose you want to make tea, and you will go in the kitchen, check if there is milk available, if there is chapati available, if there is chini, sugar available. So there is no bottom of thought. You don't need to turn on the gas. Like, you have to think, you have to act. There's need to both. And there's only action, things are very difficult. Like this can be a basic understanding. Great. And while like it shows the results on various results, not like the best approach it found was the combination of React and chain of thought. We'll discuss it later on. Just think of this, keep it in mind. Great. There's too many things. Okay, let's discuss the key contribution in the paper. It has introduced React. We know what is React. Great. And it has also performed experiments across various diverse benchmarks and 4 datasets. Great, we know that. And they also term ablations. So this is basically when, let's suppose there is a long project, there's various parameters or various methods. We keep one fixed, or we just remove it and see how it affects the entire system or entire accuracy, whatever the metric we have. So ablation is testing different part of the system by removing or changing one feature at a time is called ablation study. It's to see how it affects the performance. Great. And third was like it was fine tuning, no? Great. It was we analyzed the limitation of React under the prompting setup, like limited support of reasoning and active behavior. Performing initial fine tuning experiments shows the potential of React to improve with additional training data. So it just showed that if we perform initial fine tuning, how does it affect the LLMs, or like how does the accuracy or the results changes. So basically by fine tuning the results were much better. Okay, so the part was we introduced React, perform various good experiments, lessons, and fine tuning, which made result things better. Great, yeah. This now this is React. We know what is React. Reasoning plus action. Great. So just saying, in reinforcement learning, you will see that there is a concept of action space. So there is action space, and it is saying that in along with action space, we have a space of language, like concept of language, and language is like reasoning or thought. Really, when we work, when we like future, when we take actions, along with that, we try to store information, or like why we are doing that, what are the changes in the environment, like concept related to that. When you read more, you will get to know that is what was important. The task where we go here, for task where reasoning is of primary importance. Yeah, this can be like in React, we it's very common to see like uh, reasoning, reasoning, action, observation, reasoning, action, observation. But like we can change this. Like let's suppose there's a task where there is more reasoning. You can think of reasoning, then task, observation, reasoning, task, observation. If there is more action needed, you can say reasoning, action, then observation. Like no, reasoning, action, observation, then reasoning, action, observation. So we can change it like depending on our need. Like we can modify or things. We can uh, then we can make changes in the code. Could be done. So it's for a task where reasoning is of primary importance. We alternate the generation of thoughts and actions so that The task solving creativity consists of multiple thought, action, observation steps. In contrast, for decision making, potentially large number of action. Large number of action. Okay, my concept was great, but for reasoning, we will alternate of thoughts and actions so that task solving will contain multiple thought. Okay, like let's say the thing I discussed for action it was right, and for reasoning it was like you can read it. Things are like this. Okay, great. I won't go much into depth. Okay, domain action space, which is a defining what are the action space. But usually what is the kind of you can say tool thing. Great React prompting. So this was the result. Then is standard COT SC. This was defined. What is SC? It has already defined here. Okay, supervised SOTA is supervised state of art. This showing the result. Create rules for switching. And here we are discussing that we are using both React and chain of thought prompting. So it is showing when we use React, we will use chain of thought. So this was the best method. So we try to read this part. And this is also important, fine tuning. So basically it use 300 like samples to improve like to tune the model. Great. Here is 6 billion parameters, 62 billion parameters of palm. So this we know that I haven't discussed difference between React and code. So basically in COT it only gives the answer using the internal data. So there is problem of hallucination and label ambiguity. Great. So but in React we use live data or recent data using let's say using tool Wikipedia API. So there you won't find much of hallucination, but there is a reasoning error. Like sometimes things go into loop. Reasoning action, things like this. Okay, this is important. This one. Without that is a frequent error to React. Like it works and it never jumps out of a loop. There's a loop problem. Okay, also here is shown like after fine tuning how things get better. This is very. It says that the 8 billion parameters after fine tune formed better than 62 billion, and 62 billion after fine tuning formed better than 550 billion one. So this is just showing that how after fine tuning things get better. And earlier we discussed about the results on reasoning based, like on hotpot dataset and on fever. Now it is LF World and WebShop. So you can just go through it here. The same things are there. So there is term imitation learning. So this is just rated type of machine learning, where the model learns to perform tasks by mimicking experts. Imitation like copying things. So it is like try to copy rot learning. You can think of like try to copy the entire method. Great. So there is also all these methods. You can go through it. Okay. That's it. Yeah. There also ethics. Try to read it, and this is the basic concept. Okay then. Bye bye.